Hi everybody, I'm Greg Fishel. Welcome to bonus weather video number 2 for this week, and it is Wednesday, yes. And I alluded to this in the daily weather update that there are some interesting things about leap years that I know I was not aware of, but maybe you are or have been, and I'm just getting in on the fun here. But anyway, I wanted to talk about that a little bit, and this sort of came to light because tomorrow is the first day of spring and or when spring begins, and it's the earliest beginning of spring in 228 years, going all the way back to 1796. So a lot of this has to do with the way our time system that human beings have defined varies from the way the solar system works and so forth. And so I thought it'd be fun to get into a little bit of this. As I was preparing this, I was debating whether or not this was actually fun or not, but in the end, I think it was. So let's go on ahead and get started here. So there are some numerical nuances when it comes to our time system, and I wanted to start off by talking about those. Now, we define a year as 365 days long, or 8,760 hours in duration. But in reality, it takes the Earth 6 hours longer, or about 8,766 hours, to complete one full orbit of the Sun. So our time system is 6 hours behind after 1 year, 12 hours behind after 2, 18 hours behind after 3, and 24 hours behind after 4. So every 4 years, we add 1 day, or 24 hours, to make up for the lost time. And so that is why every 4 years we have a February 29th as opposed to sawing it off at February 28th. But did you really think it was that simple? Of course not. All right. So leap years occur every 4 years when we add an extra day to the end of the month of February, right? Wrong. At least in a few instances. Most of the time that's true, but every now and then we skip a leap year. And so we're going to talk about what those years are. The rule of thumb on this is that if a given year is divisible by 100 evenly, okay, no decimal points, then, but not divisible by 400, then that leap year is skipped, okay? If a year is divisible by 100 and 400 years, then you do observe a leap year in that particular year. So let's put this in table form here, and I'm going from the year 1600 to the year 2400, every 100 years. Well, all of those years are divisible evenly by 100, but only 3 of them are divisible by 400, 1600, 2000, and 2400. So what years do we skip? Well, the ones that are, again, divisible by both 100 and 400, then you observe the leap year in those years, but the years in between those that are not divisible by both, 1700, 1800, 1900, and 2100, 2200, and 2300, you do skip. So in those years, there will be no February 29th. And why is that the case? Well, I mentioned these numbers earlier, but I'm just putting it in table form here. The number of hours to orbit the Sun that we have defined is 8,760, which is 24 hours times 365 days. Reality, though, is actually 8766. So again, we're losing 6 hours every year, and so by the end of 4 years, we've lost 24 hours, and so what do? We add a day back in, and so that cleans the slate, we thought. But let's now shift the units to minutes, because we're going to have to get down to some precision here that if we simply do it by hours, we're going to lose that precision. So 365 times 24 times 60 is 525,600 minutes. That's our time system. Reality, though, is 525,960 minutes, okay, during the course of a year. So we are falling behind 360 minutes every year, and so we're down 1440 by the end of 4 years, and so we add 1440 back in, which is simply 24 times 60, okay? But in reality, it's not exactly 6 hours, okay? It's actually 5 hours and 48 minutes, okay, the time difference. So reality is actually 525,948 minutes and not 525,960. So Over the course of 400 years, we are going to make 100 corrections, right? Every 4 years is a leap year, at least we thought it was, right? And so you have 25 corrections every 100 years, which would mean you make 100 corrections over a 400-year period. But we are overcorrecting by 48 minutes, okay? When I made the modifications up in here, the difference, we were falling short by 348 minutes, which was a total deficit of 1392, but we're adding in 1440, which means that we're overcorrecting by 48 minutes for each of those corrections. So 100 corrections over 400 years times 48 minutes is 4,800 minutes, which turns out to be 3.3 days, okay? So we're overcorrecting by 3.3 days, and so that's why we're going to not observe a leap year in 1700, 1800, 1900, and 2100, 2200, and 2300, and that'll get us back close to where we need to be. There's still a discrepancy of 0.3 days, and I couldn't find any material, at least over a short period of time, to explain to me how you get rid of that, okay? But it certainly gets us close to where we should be so that our time system matches up in the end with the universe, or the solar system, if you will. And so that is the bonus weather video for today. I hope that made at least a little bit of sense. It took me a while to figure out what I thought was the best way to present this, and I may be wrong. And if this doesn't make any sense at all, let me know in the comments below, and we'll try to figure it out another way. But basically, all of these corrections or non-corrections are trying to get our time system, which we want to be consistent, okay? We don't want, these things changing every day, because we plan our day based on, we got to be to work at 8, we take a lunch break at 12, we go back to work at 1, we get off at 5, whatever it is. We don't want that stuff to be changing every day or every month or every year, okay? But we don't want to get to a situation where we're so far out of whack with the way the solar system works that our seasons are drifting, okay? We don't want winter starting in June, okay? So we make these corrections every so often to get us back on track. I guess I would call it a mid-course correction, if you will, and that's what really this is all about. Okay, folks, there are the credits, and that is the bonus weather video for this Wednesday. The next one coming up Friday, and the next daily weather update, of course, coming up tomorrow. So you all take care, and we will talk to you less than 24 hours from now, because it's awfully late when I'm recording this. All right. Y'all take care, folks. See you later.